they don't say particle. They say like a small, tiny marble. Then what he says like some pencil is kept, and let's assume pencil rigid. Then you'll discuss the problems. Students immediately what happen? Oh, what I'm studying is something very general. But you look at our books, no, rod of mass and length, rigid rod of mass and length. Yes. Then rigid rod, either rigid or not possible. Then what he says particle. Particle means finish or no tiny particle. We don't know that. The moment you say particle something, when you say ideal, no, then students will think okay, all these are imaginary. You take for another book, no, nowadays what mean they're changing things. They say they want like a students to analyze, so they say like a small marble. Understood, marble means okay. Then they say like a pencil made up of iron, take it to be approximately rigid. Finish. Or anybody can understand this problem. What students will do, immediately take pencil, let's assume iron, then you'll take some small stone or any bead, you'll throw that, it go collides. Finish. Or is far better at highest position in the science and technology because he is analyzing things. I don't know why our authors when will change. Hope very soon let them change so that more practical way of learning things will come into our education system. Now, so what you should do, immediately what will happen, just during collision, what actually happens? During collision, because we know collision idea. So they say, what are the forces that will be acting? An impulse will act, normal contact will act, and that normal contact will exert impulse on this. Similarly, an impulse will act on the rod. Agree this? Okay, now come for this one. An impulse acts on a rod. So what can happen to the rod? Angular impulse, angular momentum concept you applied. So just after impact, what all we can see is the rod will have, see, you come for an impulse acts on a body, then it will have momentum. So the center of mass will start moving with a velocity v naught. This is the end of the rod. Then J into L by 2, an angular impulse is set up, no? So this is L by 2. And this is J. So L by 2 and J. So how the angular impulse is acting clockwise. So therefore the rod will acquire an angular velocity omega naught. What will happen to the particle? You go back to the collision. If an impulse acts on a particle or on a body, so then what are the possibilities for this particular ball or small ball, marble, small marble, whatever if you want you can put it. So what will happen? It may come to rest after collision. It may rebound or it may continue to move with a velocity in same direction. So what I do is like I'll just assume just after impact it will have velocity, say we'll do one thing, v2 omega 2, this is v1. This is before collision, and what is the state of the rod? It was at rest. This is during collision. This is after collision. Okay, we have this much here. Then what are unknown things are there? V1, V2, omega 2. Three unknowns are there. Can we apply conservation of linear momentum? The very first thing, can we apply conservation of linear momentum? Yes, we can apply, because what is the net impulse on the system? 0. So summation of Jx is 0. So initial momentum equal to final momentum. Now what is initial momentum? Mu. Final momentum, the particle will have velocity v1, that of the rod v2. How many unknowns are there? U equal to v1 plus 2v2. Yeah. Then next question comes elastic collision. That also we can take help of this one. Can we apply coefficient of restitution? Hence we can apply. So what is this? This is a line of impact. This will be the line of impact. Then what is the velocity of the rod after impact? So velocity of point A. So applying quotient of restitution formula, E is equal to velocity of the rod, VA, will be positive. No? Anything directed towards right, I'll take positive, plus VA, plus V1, then velocity of the rod, plus U. What is the state of rod? Earlier it was a test. So since E equal to 1, so 1 is equal to, what is VA? You can write it as V2 plus L by 2 omega 2. Why it is like this? Because what is the velocity of point P? Because the rod is having both translatory as well as rotating motion. What is the velocity of any point? Due to translating motion, VA. Due to rotating motion, tangential velocity, L by 2 omega minus V1 by U. So U is equal to V2 plus L by 2 omega 2 minus V1. Desperately, we need one more equation. I'll apply conservation of angular momentum. We need one more equation. So from where to bring, how to apply conservation of angular momentum, about what point angular momentum is conserved. I'll give 1 minute time because there's the first problem. I want you to really put effort. About what point you can conserve angular momentum. About what point angular momentum is conserved. I should give even 2 minutes time, nothing there then. So just put effort, analyze. What are the points are there? A, B, O, or any arbitrary point, and a point on a ground, no? I'm giving int. Check is it angular momentum conserved about A, about O, about B, about any arbitrary point on the rod, and a point on the ground. So 5 points are there. But in the books, they are considered only about 1 point. Why they are doing like that? So if you close eyes, try to imagine gone. So what you should do, you should immediately what happen? Bring the formula, angular impulse, angular momentum equation. When you can conserve angular momentum, when net torque is 0 or net angular impulse is 0, then Li is equal to Lf. Go back to the formula. What is the formula? You have to start from here. No? What is it? When you can write Li equal to Lf, when J theta is 0, when angular momentum is conserved, when net torque is 0 or angular impulse is 0. If this angular impulse is 0, then initial angular momentum equal to final angular momentum. So now about which point you can pick up so that net angular impulse will be 0. Again, you should choose axis, no? Whenever you're writing angular impulse, angular momentum equation, what is the basic necessity condition? Where is the axis? Okay, let me do one thing. I'll start about O. And then due to this J into L by 2, this is L by 2, this is J. So how is this angular impulse due to J, which is acting towards right clockwise, L by 2 J. Right hand fingers, you have to curl R bar cross this one. So what is the angular impulse? R bar, this R bar, this is J. Then similarly, okay, this one. Now you look at this one. This is R bar, this is J. How the angular impulse due to this linear impulse will be anti-clockwise. So net angular impulse 0. So therefore angular momentum is conserved about O. Next thing, sir, what about A? Yes, it is conserved about A also. Because both these linear impulse will not set up any angular impulse. So angular is conserved about A also. There's no problem. We can conserve about A also. Sir, but B, is it conserved? Yes. Plus L into J clockwise. Here, this plus L and this J. So this angular impulse will be anti-clockwise. Net angular impulse 0. Yes, about B also angular momentum is conserved. Then what about any point on the ground? Any point on the ground means let me pick up here. Then about this point, you look at this one. any point, no? Somewhere here. Look at that yellow color line. Now some RBT point I'm picking up here. About this point P. About this point also the condition is same. This is R bar, this is J. Clockwise angular impulse. This is R bar and this is J. Anti-clockwise. So what is the net angular impulse about any point on the ground? Is also zero. So therefore angular momentum of this system, particle rod system, about what point concerned? About any point on the rod or about any point on the ground? Most fundamental, this is the most fundamental thing. So therefore what I should conclude here? That line is there. I'll show by yellow color line so that it'll be easy for you. If I draw another thing, no, you start assuming some other thing. So what is the conclusion? As shall I make it? Angular momentum of rod particle is conserved about any point on the rod or about any point on the ground. But I'll consider about O. Okay, this I can consider about any point. Okay, now I'll get into the problem. I'll consider about O. L O Z I is equal to L O Z F. What is the initial angular momentum? I think I can't minimize more than this. Yeah. Anybody, can you write initial angular momentum? Like a particle, no? It is the rod is at rest. So this is L by 2 and mu L by 2 only due to translative motion. Clockwise. Finally, particle is having angular momentum how much? I can't minimize less than this one. We'll do one thing. I'll shift it this one. Yeah, I think no. Yeah, and this one. All of you, please. They're the best problem. So almost you have some 30 to 40 numericals are there, not 1, 2. And there's a core idea enough. You can manage most of the numericals, you know. And let's come for this one. What is the angular momentum of particle after collision? mv1 L by 2. It is also clockwise. Then next, that of the rod. Rod is what? High O omega 2. But sir, why you are not writing 2mv2? This velocity v2 what will intersect the axis of rotation. What is the axis I took? About O. So about what point we are defining all this? About an axis passing through O perpendicular to plane. I'm bringing everything. Just please do see that one. So what is this? That of the particle before collision. That of the particle after collision. And what is this? Angular momentum of the rod due to rotative motion. But sir, rod is also having translative motion. But look at translative motion would describe center of mass. Okay, fine, everything. But what is axis? Axis is at center of mass. So what happened to R bar? L equal to R bar cross mv bar. No, R is 0. No, or this velocity v2 will intersect axis of rotation. So R is 0. That's why we don't get angular momentum due to translative motion of the rod. Only angular momentum due to rotative motion of the rod. Okay, now you can ask questions. Sir, I'll apply about B. So what is the best way of defining angular momentum? About which axis the rigid body is rotating, about that axis, how you can write angular momentum? High omega, no? go back, previous class I discussed some very beautiful ideas here. When you can write L equal to I omega, when L and omega are about same axis, no? When L and omega are about different axes, then you can't write L equal to I omega, then you should write L bar equal to I omega bar. Got the idea? This one. So therefore now, so definitely Arpan, I want to write a simplified mathematical equation. So therefore I'm picking up an axis about which the rigid body is rotating. The rigid body is rotating about O, so I'll define about that one. So therefore the formula will become very simple. Moment of inertia about that axis into angular velocity about that axis. Able to get this? So therefore in all these conditions what happen, I should always go and check about what point the rod after collision will rotate. About that point we'll try to define angular momentum. So that will be easy for us. Okay, what is our question now? We have to find out V1, V2 and omega 2. Let's get into calculation part. After this, I'll go for solving. This should be M Lu by 2, V1 L by 2. Moment of inertia of the rod 2M L square by 2L into omega 2. So M get cancels and also one L also get eliminated. So U by 2 or even V1 plus L omega 2 by 3. So how many unknowns are there? Check it. 1, 2, 3. Three equations, 3 unknowns. Solving them will get the required answer. So what all we have brought? Conservation of linear term, coefficient of restitution, then conservation of angular momentum. Almost maximum ideas we'll try to introduce in given numerical. Just solve it, give the values, V1, V2, solve 1, 2, 3. Anybody solve 1, 2, 3? Because give the values, this is very important. No. Anybody answer? Please try to solve it. You give the answer because like that sign I have to interpret. I'm waiting for your answers. About any point P. We'll write it. You have to solve 1, 2, and 3. Anybody answer? In terms of u, you have to bring. Answers will be in terms of u. Omega will be there. Yeah.
And V2 are U, sir. They both are equal.
Which one?
V1 and V2.
They cannot be equal. Check it.
They are equal, sir.
No, will not come. Equal will not come. V1 equal to u by 3 minus u by 3. Check it.
No, sir. It's U by 3. And
V2. 8
even
u by
that's U by 3, sir.
No, check it, check it, check it. Some others are giving some different
Yes,
answer.
sir, it is U by 3 only, sir.
U by 3, yeah, this also.
Sir, V1 is minus 2U by 3.
There's one, it will rebound, no, collision concepts.
Yes, sir.
Minus. I'll write in other color, negative, no? So solve like correctly. Because the sign I have to interpret here. Value V1. It should be negative because lighter particle collided with heavier particle, it will rebound. Minus u by 3. Yeah. You don't think simple L omega 2 is equal to how much? 3u minus 3v1. That you substitute here. You'll get v2 v1 equation. Then solve these two. You'll get one. So much of big time. Huh? All of you sleeping or really listening to my class?
Sir, omega 2 is U by L, sir.
Only u by L. Huh?
Yes, sir.
So many different answers here. Huh? If everyone uniform, okay, I could have continued. But almost 8 students, they're given 8 different answers.
Sir,
Ah.
if V1 equal to minus U by 3, omega 2 can't be U by L, sir. The third equation won't satisfy that.
So that's why I'm telling this one, you have to work out all, see that no errors will be there.
Sir, V1 and V2 both are U by 3 and omega 2 is 2U by L, sir.
check one's calculation.
Even I got the same thing, sir.
V1 how much? V1 u by 3, huh?
Yes, sir. V1 and V2 both are U by 3 and omega 2 is 2U by L.
2u by L. Will it satisfy equation? Check it once.
Yes, sir, it will satisfy, sir.
Yes, sir.
Equation 2, substitute the values. So RHS should become equal to u. Then fine, no? Mathematics. Okay, no. So these are about the angular velocities here. Sometimes v1 will be negative. Negative means it will rebound. That's all. Because a elastic collision is a lighter particle collides with a heavier particle. There's a possibility of rebounding. There's also possibility of particle will come to rest after collision. Then in that case, directly write v1 equal to 0. So you do have some questions where after impact what will happen to the particle will come to rest. If they say like that, I think problem is very easy, after collision the particle come to rest means that v1 0. Then what are unknown things v2 and omega 2? So all that will get the required answer. All situations are possible here. Getting this much, no? Okay, now we'll take the next condition.